Let's look at addition and subtraction of complex numbers. In a complex plane, in a complex plane, you can represent points of this complex plane by complex numbers, or in other words, every point, each and every point in this plane will represent a unique complex number. So let's see how we can add them and subtract them, real part and imagined part. So addition and subtraction can be done the same way we did with vectors, because the two numbers which represent the complex numbers are real numbers and imaginary numbers. They don't mix up with each other. Same way, you remember when we're dealing with vectors, we can represent a vector by unit vectors, I and j. Remember, I and j. So these two vectors also do not mix up with each other. So think of it as this is j, this is I, unit vectors. So if I were to represent a complex number z1 at point here, can draw a vector here now, vector representation, and a c2 somewhere here can represent by another vector. So how did you obtain the addition of complex numbers? When you want to add two complex numbers, you use law of addition. Or you can, it is the same, not different. You can represent a parallelogram here. You can draw a parallelogram here, and this parallelogram will give you the addition of these two vectors. This is how we construct complex numbers, or addition of complex numbers in the complex plane. You first locate the two points which which is relevant to the complex numbers. Then you make the construction like this parallelogram, or you could move this line here, move the end of the initial position of this vector to the end position of this vector, right? Then this will give you the addition of two complex numbers. So here let's call it C. Now C is given by addition of two vectors, right? This is how you construct the addition of two complex numbers in the complex plane. How do you do it? You construct the parallelogram, and this will give you the addition of the two complex numbers. So we can do that, do the same thing for the subtraction, except let's say that you want to subtract z1 minus z2. Then you already have z1 here, and you need minus z2. How do you obtain minus z2? You just have to invert the direction of z2. When you invert the direction of z2, it forms a z2 forms a straight line. Here you get z2 minus z2 point. Now again we can do the same thing here. Write this as z1 plus minus z2, right? This is again the addition of two complex numbers. In this case, this is c1 and this is the negative number of z2. Now we can construct the parallelogram like this, and therefore this vector or this point, this vector or this point will represent the subtraction of the vector. So we'll call this z1 minus z2 point. z1 minus z2 points. We'll just call this z1 plus c2 points. All right, you can, but one thing to remember here, that this length, the reduction of this length is equal to this length here between z2 and z1, same length, right? Just keep this in mind for the moment. These two sides are equal to each other. Okay, this is how you construct addition and subtraction of complex numbers in a complex plane. Right, thank you.